So hello viewers, and if you are aware about BGP protocol, then this will be a good refresher for you. And for those who are not aware about BGP protocol, this will be a very basic high level overview of BGP protocol. So yeah, without wasting much time, let's get started with this video. Now this has been the content for all of my previous protocol that I have covered on this YouTube channel. So first we covered RIP, then we covered OSPF, and for BGP also this will be the same. So for all those protocols, RIP and OSPF and the other routing protocol that we have covered on this YouTube channel, first what we do is we introduce we give the very basic overview of the protocol, and then there are certain other things such as the protocol history. Then we also talk about the packet formats, the major packet formats that the protocol might involve. Now then after that we will have a very broader overview of the protocol, and at last we will see how we can simulate or how we can configure the devices in CPT, and how we can simulate all those protocols inside NS3. So that is the content that we will be covering for the OSPF protocol as well. And yeah, in this video we are going to cover the very basic introduction, the TCP updates. So these two parts we'll cover in this video. So yeah, let's talk about the BGP. So I have been covering this routing series, the layer 3 routing series, for quite a while. We have seen the static routing protocol, then we move for the dynamic routing protocol. Then on the dynamic routing protocol, what we have covered is first we have covered is IGP protocols, so interior gated protocols such as RIP. We covered OSPF. We are yet to cover SIS, that will cover after the BGP. Now we are moving forward the eBGP, that the full form of EGP is exterior gated protocol, and that is majorly we use eBGP. So we will see the high level overview of BGP. So just to give you an idea about where all this protocol falls, this is the graph that you might refer, and you can compare all the previous protocols that we might have studied. Now let's start with the high level overview of BGP. There are two flavors which is often referred as eBGP and iBGP, and we'll see what is the difference between those. And the name for the full form of BGP is Border Gateway Protocol. It relies on TCP, so it's really different than previous protocol that we have seen. So it's completely different, and it doesn't flood for neighbors. Instead, it uses the manual discovery. So in previous protocol we might have seen that OSPF broadcast the multicast the packets to form a neighborship, but BGP doesn't do that. What BGP does is BGP relies on the manual neighbor discovery. So we configure the neighbors that we want to talk with. So that's how BGP works. Now let's get to know about certain difference between other protocols that we might have covered till now and the BGP. So manual discovery. First thing is manual discovery. Now in manual discovery, how does it differ for OSPF is OSPF relied on flooding, where BGP relies on neighbor discovery. So let's say there are two devices and we want to have a BGP communication between BGP neighborship between these two devices. So this interface might be connected over internet, so there are multiple hops in between these two devices. So that's why I have put this cloud over here. So what we does is, in BGP we provide the IP address of this particular device, or if let's say they are directly connected, we provide the interface address, that is also an IP address of this particular interface to this device when we are configuring the BGP inside this device, and vice versa on this device. So we provide the IP address of this interface while we configure the BGP over here. So that's why we call it as a manual neighbor discovery. And as BGP relies on TCP, it uses the three-way handshake before it start the neighborship. So that these are the two things that you must be aware with before starting with the BGP. And this is basically main difference between BGP and OSPF. So iBGP and eBGP, as we talked earlier. So to give you an overview of how does they differ, so let me just quickly introduce you with the AS numbers. So AS stands for autonomous system number. So that will be assigned to your organization. Let's say there is a very big organization, let's say Dell, or let's say there are certain other companies, let's say Microsoft or Google. So what they will do is they will be getting an AS number by an IANA. So basically that is the responsible to assign the ASN numbers. Now let's say we got the ASN number for these two devices. So there are, before we move to the actual difference between iBGP and eBGP, so there are certain ASN numbers that are private. So if you are aware about the concept of private IP addresses and public IP addresses, so that's the same thing for this number. So there are certain private AS numbers and public AS numbers. So private AS numbers which we can use it inside our organization, and public ASN numbers that will be required for us to communicate with different organization or over the internet. Over the internet we must require an public ASN number. So that is a different. Now let's say these two devices have BGP neighborship between them, and this device has ASN number X and this device has ASN number Y, and if let's say X is equals to Y, that means this both devices have same ASN numbers, that means it's an iBGP. So iBGP means they both devices are in the same organization. So that's the literal meaning of iBGP. In same organization also, if let's say both of the devices have both of the devices are in one organization, and if we have a different ASN numbers, X is not equals to Y, then we will have a eBGP neighborship between them. So that is the basic difference between iBGP and eBGP. So you can just by looking at this configuration of both of these devices, you can see that what flavor of BGP is running between them. Now there are certain things that you must know. So let's say if we are forming an iBGP neighborship, so let's say whenever we send the routing updates, so for those the TTL value will be 255. That means there might be a multiple neighbors in between these two devices when we have formed the iBGP neighborship. But for eBGP, what BGP protocol assume is that the devices that are connected, they are just one hop away from each other. That's why whenever we form a eBGP neighborship, the TTL value of the packet routing update sent from any of these two devices will be 1. Although the configuration is modifiable, you can set the TTL value according to whatever the need that you might possess. Now, in contrast of BGP, what OSPF does is OSPF doesn't have the exterior gateway exterior flavor of the OSPF. So OSPF falls under the iGP protocols, and that's why it's just used for interdomain. It's not used for interdomain routing protocol. So that's the difference between BGP and OSPF. Now, if you have a little bit knowledge about OSPF, so the purpose of OSPF is to share an entire network with all the nodes that are connected on that network. But in contrast with BGP, so there is a very different route propagation happening in the BGP. Although we will have a brief overview of this route reflector and what we are seeing over here in upcoming slides, but just to give you an overview, so when we are using eBGP, so routes that are learned via any other eBGP neighbors that are advertised directly. So routes are propagated directly. But let's say if we have iBGP neighborship between the two devices, so we either need full mesh configuration of all the devices to share all the routes, or we need a route reflector to reflect the routes that are learned from another eBGP neighbor or another iBGP neighbor. So routes that are learned via so let's say if in this ASN 65001 we have iBGP running, so routes that are learned from C to B, that B will not be directly advertise those routes to E. So that's why we need a route reflector. So more on this route propagation we will see in upcoming slides. Now this slide is not necessary, but I just thought that this is a very good calculation stuff that might be asked in certain interviews. So let's say if we have n nodes in certain network and they are all running an iBGP, then if we are not using route propagator or route reflector, then what are the connections that we might need to have to share all the routes from every other node to every other node. So let's say if we have 4 devices and we want to share all the routes for to all the devices, and we don't have the route reflector, then in that case we need a full mesh connection. So if you are aware about graph theory and we have 4 nodes and we want to have all the possible edges, then that shortcut to find that edges is n into n minus 1 divided by 2. So over here we have 4 nodes, so we can just put that 4 in place of n over here, and that will be the final connection that we might require if we want to share all the routes. Instead, now they will ask a second question. Let's say if we are using route reflector, then what are the possible connection that we need? What are the minimum connection that we need? So in that case, what we want to answer is just n minus 1. What you can do is you can take any node and you can connect that node to every other node. So that's why, let's say if we have 4 nodes, we can connect to all the other nodes. That's why n minus 1. So these are the maximum or minimum connection that we might need if we want to propagate our routes that are learned via IGP to all other neighbors. So that's the basic math calculation that I wanted to just bring up. Now let us see the BGP operations that are done when they are forming a neighborship, and after the neighborship what happens. So this will be a very brief or very high level overview of BGP operations. So now let's just look at the BGP operations. So as you can see on the screen, this is the literal state transition that might happen when, let's say, we have 2 devices that are trying to form a BGP neighborship. So we are not bothering about whether this is an iBGP or eBGP because the steps will remain same. So first, let's say we have configured the BGP configuration, the router has been configured with the BGP, both will be in idle state. Idle state means they are waiting for the neighbors to be configured. Now when they are in idle state, what they will do is they will try to form a TCP session with the devices that we might have configured on the router configuration in both of these devices. Now this TCP handshake will happen. So basically sync packet will be sent, SYNAC will be sent, then acknowledgement will be sent. So this is the 3-way handshake that will happen between these 2 devices. After the handshake has been done, they will go for the next state transition. So the next state will be connect state. Now the connect state will throw you the information that both devices are trying to make the TCP connection. So let's say if we are yet to configure the TCP connection, then it will remain in the connection state. Otherwise, if let's say we have the connection successful, then it will go for active state. So in active state, what it does is, let's say if the TCP connection has been failed, then it will try to connect with the device that has been configured on the devices over here. If failed, otherwise it will show as an active state. So that's the state transition happening from idle to connect to active. Now once the TCP connection is up and both the devices can talk on TCP, the BGP open message will be sent. So BGP open message will be sent over here, and BGP open message contains the information about devices. So let's say what is the router ID. So if you are aware about OSPF, in OSPF also we configured the router ID, so that's literally same for BGP also. Then let's say certain timers will be there in the BGP as well, as compared to what we have seen in the OSPF. So there will be hello timer, or not hello timer, the keep alive timer, the dead timer, and all those different timers are also there in BGP. So both devices need to match those values. So that's why BGP open message will carry all this information, and both of the devices will verify if they are matching with those configurations to form a neighborship. And if those values are matched, we will have a successful neighborship between these 2 devices. So basically, when the BGP open message is sent, the state transition will be from active state to open sent state, and that literally means that we have sent the BGP open message and we are waiting for the keep alive message. Now what will happen is, in reply of this BGP open message, this device will also send the BGP open message, and both will try to verify the information, and one of the device will send the keep alive message. Now when we send the BGP open message, in reply we want the keep alive message. Now keep alive message is to keep the connection alive, so that's the literal meaning of keep alive message. So that's the another message format of BGP. Now once we receive the keep alive, we will be going on to this state which is called open confirm state. And when we receive the BGP open, we will go for the open confirm state, and that literally means that we are waiting for the keep alive. Now once both of the device will start to receive keep alive, what will happen is they will both go for this established state, and that means that both of the device now successfully establish the connection. So BGP neighborship is formed. Now they will start to exchange the routing information. So that's literally the high level overview of BGP operations that will be happening in the background. Now just to give you a little bit of troubleshooting advice, so let's say the device has been stuck in any of these two states, which is connect state or active state. So there might be an issue with TCP connection or IP reachability, or there might be a access control list ACLs, or let's say there might be a firewall which might be blocking port number 179, and this port is being used by BGP to communicate the other devices. So the BGP will be running on this port. So that's why you should look for these three particular reasons if you want to debug why the neighborship is stuck in any of these two states. Now it might get also stuck in open sent state, and you might follow any of these steps to debug what might be the issue. So if let's say device has been stuck on open sent state, then there might be an issue in configurations, or that might be some value that might be mismatched. There might be an authentication issue. So let's say one device has been configured to use some authentication, another device that to which we were trying to make a neighborship that might not be using authentication. So that might be an issue. And let's say some setting of BGP open message are rejected. Let's say keep alive timer mismatched or dead timer mismatched. Then they won't form a neighborship. So yeah, those are the things that you might want to have when you are troubleshooting the BGP neighborship. So yeah, that's it for this very brief overview, high level overview of BGP protocol. You might have got the idea about how BGP works and the basics of it. In the next video, we are going to see that what are the packet formats, what is the BGP history, and how the BGP packets are transferred. So yeah, that's it for this video. We'll meet in the next one. Till then, keep learning and keep exploring.